Hey everyone, welcome back to the channel. Today, we're diving into something super exciting for all you tech enthusiasts out there, architectural patterns. These are the building blocks of scalable, efficient, and robust software systems, and I'm going to break them down for you in a simple, easy-to-understand way. Let's get started. First up, we've got event sourcing. This pattern is all about logging state changes to enable audit trails. Imagine a client interacting with a service. Next, let's talk about component-based architecture. This one's a favorite for UI development, especially in mobile apps. You break your app into reusable components, think of them as Lego blocks. You've got back-end components handling the logic and front-end components for the user interface. Now onto client-server architecture. This is the classic setup we see everywhere. Clients like your laptop or phone send requests over the internet to a central server, which processes them and sends back responses. It's straightforward and widely used in web applications where you need a clear separation between the client and the server. Let's move to serverless architecture. This is a game changer. You got a web app talking to an API gateway, which then routes requests to various services like authorization, content delivery, or user management. The beauty here is that there's no server to manage. Everything is event-triggered, and it scales automatically. Plus, you can integrate with external databases or APIs effortlessly. Shifting gears, we have event-driven architecture. This pattern is all about asynchronous, loosely coupled components, making your system super scalable. You've got a publisher sending events to an event broker, which then notifies subscribers. These subscribers can react to the events, like updating a database or triggering another action. It's great for real-time systems like notifications or messaging apps. Next up is layered or N-tier architecture. This one's structured into layers to keep things organized, but it can cause bottlenecks if not designed carefully. You got the presentation layer for the user interface, the business layer for logic, the persistence layer for database interactions, and the data layer for storage. Each layer has a specific role, making it easier to manage, but sometimes slower due to the layered communication. Now let's explore microservices architecture. This is all about breaking your app into small, independent services that are scalable and flexible. Imagine an API gateway routing requests to services like shopping cart, discount, or ordering. Each service has its own database and can be deployed separately. It's perfect for large-scale apps where you need agility and independent scaling. Then we have monolithic architecture. This is the traditional approach, a single code base that's tightly coupled and hard to scale. All your clients connect to one big app that handles everything, often with a load balancer to manage traffic. It's simpler to start with, but can become a nightmare to maintain as your app grows. Finally, let's look at an e-commerce example. You've got a shop UI where users interact, and behind the scenes, you've got services like catalog, shopping cart, and order service, all connected to a relational database. This setup can use any of the patterns we've discussed depending on your needs, like microservices for scalability or event-driven for real-time updates. See you in the next video.